everyone, welcome back to mahasarkar.co.in. In previous videos, you have learned about first law of thermodynamics, zeroth law of thermodynamics and thermodynamic process. The thermodynamic process is one in which the change in the volume, internal energy and work done are considered. One of the important process in the thermodynamics we are going to discuss today, that is called isothermal process. Now, when we discuss any thermodynamic process, we used to discuss three important parameters: temperature, pressure and volume. When changes occurred in this system, then we are going to discuss the every system with respect to these parameters. So if you remember, we have learned that according to Boyle's law, if the temperature of system is constant, temperature of gas is constant, then the pressure of given mass of gas is inversely proportional to its volume. When temperature is constant, so P is inversely proportional to V, P is equals to K into V, K into 1 upon V, that is PV is equals to what? Constant. So if I change these parameters P and V to from P1 V1 to P2 V2, then still it is going to remain what? Constant. This was the Boyle's law, in which the important parameter of system is constant, that is temperature is constant. So what is isothermal process? Then isothermal process is the process in which the temperature of process remains constant, then the process is called as what? Isothermal process. Now this system is called as what? Isothermal process. The process in which temperature is going to remain constant, means delta T is going to be 0. Now we know that when delta T is 0, then if I consider any gas enclosed in the cylindrical vessel with movable piston, and if the temperature of that gas is constant, if delta T is 0, that is no change in the temperature if takes place, then the gas molecule will not change their kinetic energy. So delta kinetic energy is also equal to what? 0. When delta kinetic energy is 0, therefore we will say delta U is also what? 0. So the system in which temperature is constant, so that the change in kinetic energy of the system is constant, correspondingly internal energy gained by system is also 0, then that system is called as what? Isothermal process. Let's derive the expression for work done in the isothermal process. Now, as I said here, suppose let Vi be the initial volume of gas, Vf be the final volume. Okay, when heat is given, its volume changes from Vi to Vf. Now, by definition, if you remember, by definition, work done during small change in the volume, of gas is given by, or volume of system is given by, dW equal to P into dV. What is dV here? That is what? Final volume minus initial volume. So P into dV, if I consider, then if I want to find out the total work done here from change in the volume, so if I say the total work done during change in volume from Vi to Vf is, How to find the total work done? Then we know that there is one important method called method of integration. So I can say integral W is equals to integral of what? dW. From where? Vi to Vf. Okay. Substituting the values of dW, what we will get here? Just see, if I substitute the value of dW, then what we will get? Then I will get here equal to Vi, integral of Vi to Vf from dW is what? P into dV. Okay. We know that by ideal gas equation, PV is equals to what? nRT. Implies what is P equal to nRT upon V. So if I replace this value here in equation number say 2, this is equation number 2, then what we will get? W equal to, see, substitute the value, integral of Vi from Vi to Vf of, instead of P, now I am writing this nRT upon V into dV. See, N, R and T are all constant. Since T is also constant here, then I can say here that nRT constant, integral from Vi to Vf of dV upon V. See now, this is the integration. If you have gone through the formula, integration of f dash x upon f of x dx is always equals to what? Log of x plus c. So using this is function v and its derivatives in the numerator. So we can say nRT into ln of v from where? Vi to Vf. So if I write this properly, nRT into ln of Vf minus ln of Vi, then according to the rules of integration, upper limit minus lower limit, but it is like log of m minus log of n, so it is nRT into ln times Vf upon Vi, or nRT into 2.303 times, it is ln, that is when it will have base e. So in decimal form if I write, then it will be log of Vf upon Vi. In this equation, since there is no internal energy, since there is no change in the internal energies takes place, then since delta U equal to 0, then according to first law of thermodynamics, delta Q equal to delta U plus W. So since this is 0, so delta Q can be equal to W. But what is W? Then it is what? nRT 2.303 log of Vf upon Vi. This will be the equation which is valid in isothermal process. Now, if I plot the graph of pressure versus volume, that is PV diagram for this, then I will just plot a short graph. So if I am plotting say volume along x-axis and pressure along y-axis, then what is happening? Initially pressure is less, volume is more, and then it goes on decreasing. So corresponding values of pressure and volume, corresponding values can be plotted here, Pf, Vf. Okay. So this graph indicates that the pressure and volume curve is exponentially decreasing curve when isothermal processes takes place. So during isothermal process, entire heat given to the substance is converted into work. This is one of the important points that we have to keep in mind. Okay, so what is isothermal process in short? The system in which the change in the temperature is 0, that means change in kinetic energy of gas molecule is 0, that means change in the internal energy gained by the substance is 0, then that system is called as what? Isothermal process. So if I go through the mathematical derivation, then work done is equals to Vi from V, integral of Vi to Vf of P dV. P is replaced in terms of ideal gas equation, then I can get the equation of work done. So according to first law of thermodynamics, since delta U is 0, you will get delta Q is nothing but work done, and therefore delta Q equal to nRT 2.303 into log of Vf upon Vi. In this case, if I plot the graph of pressure versus volume, that graph though I have plotted in a small diagram, but it is clearly mentioned that it is exponentially decreasing curve. I hope you understood today's article. Thanks for watching mahasarkar.co.in. Have a nice day.